start with, I'll wait for the recording to come up. All right, we are going to start with chapter 2 and 2.3 in particular. So we're going to skip sections 2.1 and 2.2. They're not relevant to what we're doing. And this should be the very first page that you see in your handout. So the very first scatter plot, which is a picture of some data. The very first scatter plot has these two variables. It's your leg length on the side and your tibia length on the bottom. And there's a relationship between these two. And if you can take a look at the diagram here, your tibia is the inside bone of your shin. It's the bigger inside bone. The fibula is the outside one. So tibia, inside, fibula, the smaller bone on the outside, and then you've got one of the bigger ones, the femur, okay, which you do not ever want to break that, that's for sure. But you've got a relationship between these two. And I've got 3 questions for you to either agree or disagree. So take a minute, read each question, and you circle agree or disagree, and then we'll move on to the next one. All right, let's take a look at the first one. The graph shows the plotted points rising upwards to the right. So just like you read from left to right when you read this sentence, you guys don't read this way. You always read from left to right. As you from left to right, what is happening to these points? As soon as I hit my graph, do you see how we are going up to the right? So as we move from left to right, the points are rising upwards to the right. We will put agree. Okay, hopefully you have that one. As the length of the tibia increases, the length of the leg increases. As these numbers get bigger here, so as we increase and get bigger and bigger and bigger and bigger, because that's the way the scale works, you see that we are getting bigger and bigger and bigger here, because when I go down to this point, we're up higher here on the graph. As your tibia length increases, as this bone increases, your whole leg length increases, and that makes sense. I don't think my shin is going to increase and my femur is going to shrink. I don't think it makes sense. The whole leg would increase, so we are going to put agree. And it says the graph can be used to determine the length of a person's leg if you know the tibia, and this is what we're going to get to later on. But what I would say now is, do you see how I can almost represent all these dots with that green line? If somebody told me that their tibia was right in this area right here, I don't think you would say that their leg length is right here. You would say, all right, your tibia is here. Let's go right up until we get kind of into our dots and go right across. And I don't know for sure, but I'm thinking your leg length should be somewhere in there. Does that make sense to you? So I would also put for this one, and I just did a spotlight here. I would also put for this one, agree. Okay. The next one. This graph shows the distance from a basketball net and the number of baskets you make. Here's the graph. Answer agree or disagree for all of these ones. Your distance from a basketball net and the amount of baskets you make. All right, this graph shows the plotted points rising upwards to the right. Are the dots going upwards to the right like they were in this one? I would probably disagree with this because as we go from left to right, do you see how they're falling? I would say disagree for this one. I'll put disagrees as yellow. Disagree. Next one, as the distance from the net increases, the number of baskets made decreases. Let's go up and let's see this person right here. This person takes 10 shots from right here. And if they're anything like me, let's use me as an example. If I was right underneath the basket like this and you gave me 10 shots, I would probably sink 8 or 9. One would bounce out, I would brick another one off the back or something like that. But I would sink most of them. I grab all 10 basketballs and I move back to the free throw line. I take 10 shots from here. I'd probably sink from the free throw line, I would say 5, half of them. Then I would move back to the 3-point line. And I would take 10 shots and maybe sink a couple. But I would miss a lot more. And then I grab them all and I go right to half court. And I baseball throw them from right here. And if I sank one of them, I'd be running around the gym like I just won $1 million. Okay? But notice what's happening here. As your distance from the basketball net increases, the number of shots that you would make is decreasing. So right here, as the distance from the net increases, the number of baskets made decreases. I agree with this. I think the farther away you are, the less likely it is for you to sink them. Now you got some NBA players, Steph Curry and all these guys that are now shooting three-point shots from 10 feet behind the arc, you know, and they kind of changed the game. And they're probably more comfortable shooting shots from there because they practice all the time. But a normal person, you would disagree. Or sorry, you would agree. The graph can be used to determine the number of baskets you made if you know the distance. Well, put it this way. If I know I sink 5 from here and I sink 2 from here, do you think you would know how many I would sink in between? 5 from right here, 2 from right here. How many would I sink in between? Would I all of a sudden sink 10? No, I would probably sink 3 or 4 between 2 and 5. So you tell me exactly how far away I am. And just like the other one, I'll put this green line here going kind of down to the right. You can see how my dots kind of fit in that type of a pattern. And you tell me how far away I am. Sir, you're going to be this far away. I would say, okay, I would sink about that many baskets right there, whatever that number is. Or you could tell me, you know what, sir? I want you to sink 4 baskets, exactly 4. Where should you shoot from? You go to wherever 4 is and you go across and you say, well, I should shoot from right about here. But you can use your graph to help you, okay? Last graph. Oh, and by the way, down here, this is, the graph can be used to determine the number of baskets. That's an agree. Now, what do you notice with this one? Age of a house and the price of a house. The graph shows the plotted points scattered. If you take a look at the first 2, am I able to take a line and kind of make some type of a trend here? My answer to that is no, okay? We're not able to do that. So these dots are way more scattered. It's almost like I can put a circle around them and not an oval. These are really scattered. What this means is if you have a really new house, it could be worth not too much, or it could be worth a whole lot. But just because you have a really old house doesn't mean it's not worth a lot. It could be worth a lot. You don't know how much your house is worth depending on the age. There's some houses in Walkerville area that are hundreds of years old and they're gorgeous houses. And then there's other ones along the lake that somebody hasn't been in years and they are just withered to nothing. Okay? You can't tell from the age of a house how it's going to be. So for the very first one, this shows the plotted points scattered. I would agree with this. As the age of a house increases, the price of a house increases. No, not necessarily. It could decrease. And the graph can be used to determine the price of a house. If I told you your house was this old, do you know for sure how much it costs? The answer is no, disagree. Okay? Everybody's good with that one? All right, let's turn the page. What I'm going to do is I'm just going to get a little practice with you guys on being able to plot points. Now, plot the wingspan of these 18 birds. Okay, and here's what we're going to do. I'm going to just get you started and then turn you loose. When we plot the points, the first column always goes on the side, or sorry, on the bottom. The first column of your table right here always goes on the bottom. And then the second one always goes on the side. So when you plot You always move this way first, then you move up and down second. But you always move across or back and then up and down. Very first point we're going to plot is 12 and 35, and I look for 12 and I don't see it exact. But I do know 12 is just before 15. This is 0, this is 15, so 12's got to be somewhere in here. In 35, you go straight up until you get just past this line, and I'm thinking your first point is going to be somewhere in that area. So we're going just across. I don't get to use this function too often. So I'll go like this for a second. And you can see that I've gone over to about 12, just before the 15, and up just past the 30 to 35. All right. So we now have our first point. I usually just put a little dot when I've got a whole bunch of these. I usually just put a little dot to help me keep track of which ones I've done. So first one's done. Now 120 and 300, all the way over to 120, which is a really nice point to have, and all the way up to 300. This one's an exact point right between those two lines right there. Done. You guys go ahead and plot the rest of these points. Always move across first, 75, and up to 250. There's 240, 250 is probably somewhere in there. All right, so you guys go ahead. I'm going to plot the rest of my points. You can plot yours. There's no way you can get these points exact. You just try to get them in that general type area as close as you can. Notice the point with 124 is just past 120. You're a little bit off your grid, but that's fine. No big deal. When you get your scatter plot done at home, just raise your hand and keep your hand in the air there, okay? Don't physically put your hand in the air at home and keep your hand in the air at home. Just hit your little button that shows your hands in the air, okay? I do. Look at that. That's the best pencil sharpener in this room. Now, when you get your plots pointed, you can look at the screen and you can see where my points are. Are mine exact? No, they're close. They're in a general area, but they're not exact. It's going to be hard to get some of these numbers exact, but as long as you're in the general area, you get the general pattern of what these dots are doing. Okay, so hopefully your graph looks similar to mine. Maybe not exact, but just similar. Okay. Looks like the bottom's going up by 15s, so you would have to kind of break it up into maybe 5s, you know? Whereas the sides are going up by 30, so when you break it up into a third, you get like up by 10s every 1/3. Just kind of gauge kind of where you're at. So when you are done, put your hand in the air. You guys good in class here? So hopefully you have a pattern looking something like mine. Now, if we had to describe what these dots look like, how would you describe these dots? If you remember on the front, when we looked at the leg length and the tibia and the basketball net and so on, we were talking about up to the right, down to the right, scattered and so on. How would you describe these, Braden? Up to the right. They do go up to the right, for sure. They absolutely go up to the right. If you take a look, the majority just go up to this right in this direction, okay? Now, when you take a look back here, they're not as tight together as this one, but they do still have that general pattern. The way that I always was taught was if you put an oval around them, does the oval go up to the right? And you can kind of see, oh, I missed that point, sorry, it should be in there. That point should be just in there. But you can see how the oval does go up to the right. So there is a general pattern. What does that mean in terms of our two variables, which is the length of a bird, like how tall a bird is versus their wingspan? What does that mean in kind of general in real life between a wingspan and the height of a bird?
Bigger the bird, bigger the wingspan.
Yeah, and that makes sense. The taller the bird, the wider the wingspan. So let's just answer those two questions down here. So describe the pattern in the dots in general. Let me just switch this so it's easier to read. So in general, the dots rise to the right. That's basically what's going on there. So what does that mean in terms of the relationship between the two? As the length of a bird, which is like their height, increases, their wingspan also increases. So that's basically what it's saying, that in general, the taller the bird, the wider the wingspan. Okay? So is everybody okay there? All right, now when we look at this, in general, that's what we see, like up to the right. But then we have this bird here. This looks like a bird that is what? Very tall or not too tall? When I kind of highlight that point right there. Is that a really tall bird or not a tall bird? I hear tall, I hear moderate. Just the length of the bird, just the height of the bird. Is it a really tall bird, or is it a short bird, or is it in the middle? The length, if you take a look, you've got to go all the way down this scale. You're even past the last number. This is your tallest bird. That's your tallest bird. But what do you notice about this bird's wingspan? It's not nearly the wingspan of some of these other birds. You've got your tallest bird and it doesn't have that big of a wingspan. What kind of a bird might that be? Anybody know of a really, really tall bird? Doesn't have a very big wingspan? Anybody ever hear of an emu? Ostrich? They're very, very tall birds. They're massively tall, but they don't even fly. Like their wings don't have to be big enough for them to fly. They have a little bit of a smaller wing set. Anybody ever watch Sesame Street? Big Bird? Tall bird. It's a big bird, right? That's why they call it Big Bird. Big bird, but the wings aren't that big. Okay? Those birds don't fly. They don't need them to be that big to fly. So this may be like an ostrich or an emu or maybe like a big bird, you know, that type of a situation. It's a bird that has a wingspan less than what you would expect. You would almost expect the bird's wingspan to be up in here, right? To keep this pattern going, but we will get to those points later, okay? Perfect, all right, next page. This one right here, did everybody have that in front? We're gonna sum up what we just did here, okay? So you guys have this page in front, just copy out exactly what I'm doing, and let's start with the front. A scatter plot is a graph. This is a scatter plot right here. These were all scatter plots right here, right here, right here. These are all scatter plots. They're actually just pictures. It's a graph that shows the relationship between exactly two variables. No more, no less. Always two variables. It's your tibia length and your leg length, two variables. It's the distance from the basket and how many baskets you make, two variables. It's the price of your house and the age of your house, two variables. Or the length of a bird and the wingspan, two variables, always two. The points in the scatter plot often show a pattern, or when something is a pattern and it goes over and over and over and over, we call this thing a trend. When something happens over and over and over, we call it a trend. There is a trend to this scatter plot. As the length increases, the wingspan increases. There is a trend in this scatter plot. As the tibia length increases, the leg length increases. There is a trend in this scatter plot. As the distance from the basket increases, the number of baskets made decreases. And there is no trend in this scatter plot, nothing to follow. Often there is a trend, but not always. And from this pattern or trend, you can describe the relationship of those two variables. So if you were like my mom, when I was growing up, every birthday I would go up to that one door frame and she would grab a pencil and she would put a little mark on that door frame and she would write my height at a certain age. Anybody else have a parent that did that? My parent did that. I do that with my daughter now. So you can see the growth chart as they grow. It's kind of neat to look back. And even now as an adult, I don't get my height taken anymore on my birthday. But when I go over to my parents' place with my daughter and they're playing with the grandkids, I'll see that door jamb every so often and I can see my height as I was growing, which is very neat. So this is the table that somebody gave us. It says Julie gathered information about her age and her height from the markings on the wall in her house. So her mom did the same thing. So you can see the two variables, age and height. And what we have here is just raw data. We just have these numbers in a table that are forming a pattern or maybe not forming a pattern. I don't know, but it's just raw data comparing two variables. What we're going to do is we're going to turn this into a picture called a scatter plot. Table, graph. Table is raw data. The graph is more of a scatter plot. So here's what we're going to do to start. And these are scatter plot basics. And these happen for every single one. Okay? Whenever you have a table, The first variable, the very first one, always, always, always goes on your bottom axis down here. There's no picking and choosing. My first variable is age. Guess what I'm putting down on the bottom axis? Age. I thought I had that there. Type that in then. Down on the bottom, age, and this is in years. So we label the bottom so anybody looking at this scatter plot knows what we're talking about on the bottom. Okay? If age goes on the bottom, what has to go on the side? Height in centimeters. So I'm going to type that out. The second variable always goes on the side, and I like to put what the measurement is in centimeters or years or days if I can. I like to put that in there. Okay? So no guessing whatsoever. Age, bottom, height, side, always. Okay? So now we have to title this thing, and this is where it gets a little bit, not confusing, but you just have to memorize. Height on this side goes up, and it's your first variable. Age comes up this way, and it's your second variable, and we just put verse in between. So even though my first variable is age and it goes on the bottom, it's the second variable in my title. But my second variable here goes on the side, it's my first one. The way that I always remember this, I loved patterns in math. The way I always remember this is take the shortest route to the top. For height, the shortest route is right here, right at the very beginning. It's not to go all the way to the second variable. The shortest route is right here. And for age, it's not to go all the way over to here. Age is to go right to here. It was the shortest route. So the title of this is height versus age. If I could spell height versus age. There it is. Okay. Now, unlike our scatter plot we did right here with the bird's length and wingspan, do you see how the scales were given? And the scales were given? Over here, they're not. So we have to create them. So on the bottom, we have to come up with what would be a good scale to use down below here. So, is that locked? Why would that be locked? So what we're going to do is we are going to come up with a scale to use on the bottom. The variables that I'm going to use are the numbers from 1 all the way to 8 for my age down below. Okay, so what should we go up by here? If I went up by 0 to 1, skip a line, 2, 3, 4, 5, I run out of room. So I'm probably going to want to go up by every line worth 1. So I'm going to start with 0, and I'm going to put it right here, and I'll type because I type neater than I write. But I'm then going to move to the next line, and I know that this is a 1. The next one will be my 2. Then I'll have my 3. Then I go to my 4, 5, 6, 7, 8, 9. Let me go one more. And 10. Okay? So now I know exactly what each line represents on the bottom. And I go to the side and I say I've got to create a scale here. Would it be worth it to go 1, 2, 3, 4, 5, 6, and so on the side? Why or why not? Should I keep the same scale and go 0, 1, 2, 3, 4? Phil?
No, because there's not even like one of their kind numbers, like 70, 80.
You have the number 70, 82, 93, 98, 106. You're not going to be able to get that on that scale. What would be a good scale to go up by here to get those numbers on there?
By 40.
By 40, so let's go 40, 80, 120, 160. I'm already done. 20, 40, 60, 80, 100, 20, 40. I like that. I think that would work. You could go by 15s. I think 15 would work too. 15, 30, 45, 60, 75, 90, 105, 120, 135, 150. 15s would work too. Your choice. What do you guys want to do? 15s or 20s? 15s? You guys go with 15s at home? So let's do the following. I'm going to start with 0. This goes right on the very bottom. My next one is going to be 15. So 15 comes with me right here. You are 15. And what I can do is I kind of know what these numbers are. So here's what I'm going to do. I'm going to cheat, if that's okay. 135, I believe 150 is my last number. 135, 120, 105, 90. I go to 75, to 60, to 45, to 30, to 15, to 0. So now all I have to do is shrink this down just a little bit. Put all those to the right. And I think I can sneak my scale in. Right like that. Okay. You guys okay with that there? Everybody's good? Okay, do me a favor, plot your points. Plot your points on your scatter plot. When you guys are at home and you've plotted your points, put your hand in the air. Okay, so plot those points. Hopefully you have a graph looking something like mine. All right, now we're going to describe this, Mateo, a couple different ways, all right? So we're going to describe this relationship a couple different ways once you plot your points. Here's the first thing that I could ask you, okay, on your test on Monday or Tuesday. I could say describe the trend in data. And here's what I want you to always remember. Whenever you see data, remember a 4-letter word starting with D. A 4-letter word starting with D, data is dots. Do you see the two? Data, 4-letter word starting with D, dots, 4-letter word starting with D. Data is dots. Just tell me what the dots are doing. What are the dots doing? Are the dots rising to the right? Are the dots falling to the right? Or are the dots scattered? In this case,
increasing to the right?
Yes, so the dots are rising to the right. That's all you have to do if I ever ask you to describe the data. Data is dots, okay? But another way to describe this is the relationship. And as soon as you have the relationship, you are now going and using your two variable names right up here. You're using age and you're using height. And here's what you're going to do for me. It always starts the exact same way for relationship. It's as the bottom variable increases because we want to know what's happening as this variable increases. So we will say as Julie's height increases. Or sorry, as her age increases, my fault. The bottom variable is age. As her age increases, we ask ourselves, what's happening to the other variables? So what's happening to her? And in this case, as her age increases, her height also increases. It's going up to the right. Does this make sense that the older she gets, the taller she gets? Yes, as you grow, you get taller and taller, okay? Is everybody good with that part? No problems there? Now, I'm just going to show you a picture here. Order, bring to the front. I did this with a different scale. Take a look what I did here. Do you guys see your scale that we use up by 15s on the side? I did this exact same one, but I went up by 10s. Do you see how we get a very similar type graph, very similar type shape, even though I went up by 10s here instead of 15s? I was able to go up by 10s. All right, still the same shape of the graph. So don't worry about your scale. It doesn't matter. You'll still get the same general pattern. All right, down to the bottom. Variables. The independent variable. We give a special name to the independent variable. It is always this variable right here. This is your independent variable, which is always the variable on the bottom and always the second one in the name. That's your first variable. It's your independent. So the independent variable is located on the horizontal axis. Whereas the other variable we call the dependent variable is on the vertical axis. So in our case, our horizontal axis is the one like the horizon going straight across the water line. Horizon, horizontal is across, vertical is straight up and down. So which is our independent variable? In our case, it's age. In Julie's life, what depends on her age? It's her height. Her height depends on her age. The older she gets, the taller she gets until she stops growing. Okay? Everybody okay with that? You guys good at home? Little hint. The independent variable always comes first in your table of values. So when you have your table of values, that's always your independent, that's always your dependent. That's always your independent, that's always your dependent. So when you have a table of values, your first one's always independent. All right, you guys good? Any problems there? I'll give you a second to copy this out. When you guys are good to move on at home, just put your hand in the air there, okay? You guys good here? So whenever you're given a table this way, independent, this goes on the bottom of your graph, dependent, that goes on the side. Whenever you're given a graph this way or a table this way, this is your independent, goes on the bottom, this is your dependent, goes on the side. Okay, so let's move to this scatter plot. We're going to do this together. Okay, so when I take a look at this scatter plot, here's what it says. The following table shows a height of corn in a farmer's field over a 6-week span. So over 6 weeks, we started to graph, come up with a table for the height of the corn. Let's create, first question, label each axis with the correct variable and title of the scatter plot. Okay, what should go at the bottom of your graph? What should go at the side here? Sana, what do you think? How did you know that for sure? Table first, this goes on the bottom, automatic. Height of corn is second, this goes on the side. So down below is the length of time, on the side is the height of corn, but when we title this thing, make sure you put the height of corn first. And then the length of time second. So that's how you would title it. Make sure you leave a little bit of space there so you can put your scales on your numbers. All right, now we've got our 2 axes labeled. Always label your axes and put a title. Now we're going to go to the scales. Let's just start with the bottom, the length of time. What should we go up by to get all of our numbers from that table onto the graph? What would be a good scale to use on the bottom? Phil, what do you think?
5.
By 5s? You want every line to go up by 5s on the bottom?
Oh, no,
1s. Now, just don't write this yet, okay? If I make this 0 and then 1, 2, 3, 4, 5, my 6 would go right here. Do you see that I'm already done my table and I'm not even halfway? Do you see that? So instead of making every one, what do you think we could do here?
Every few lines.
Yes. What if we went 0, this is 1, this is 2, this is 3, this is 4, this is 5, then my 6 becomes this line right here. I like that scale a little better. It spreads out your data, okay? You don't want to cram it in. So our scale on the bottom is every line is going to be worth half of a week. Do you understand that? Our scale would be a half, so every line's worth a half, but we don't have to worry. We'll label it all as the following right here. Every other line is what we're going to label. Now, please note the following here, because this is something that you guys do wrong. People online, make sure you watch this, because I get this no matter how often I say it. No matter how often, I always get people doing this wrong on their test. I'm just going to show you this scale right here. I'm going to blow it up here. Do you see how between 1 and 2 I skipped a line? Between 2 and 3 I skipped a line. Between 3 and 4 I skipped a line. It means every line's worth a half. This is 1, this is 1.5, 2, 2.5, 3, 3.5, 4, and so on. Make sure you skip a line between 0 and 1. Way too often people will start with a 1 on the very first line, then start to skip. If you're going to skip between 1 and 2, and between 2 and 3, and between 3 and 4, you skip between 0 and 1, 2. Don't put your 1 here and then start to skip. Does that make sense? If you did that, what you're saying is every line's worth 1. Now every 2 lines is worth 1, and you've got an incorrect scale there. Does that make sense, you guys? On the side, what should we go up by? What would be a good scale to start at 0 at the bottom and go up so we get our biggest number, which is 70, somewhere up in this range up in here? We want to get 70. What would be a good scale to go up by? 5. Let's take a look. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70 would be right there. I love it. Going up by 5s is a really, really good scale for the height of the corn. So when we take a look at the following, you don't have to label every line. Don't make it look too congested. I labeled every other line. So to blow this one up for you, for the height of the corn, you can see how skip a line between 0 and 10, and then keep skipping a line between 10 and 20, 20 and 30, 30 and 40, and so on.
Sir, but if we go up fives, would we not skip lines?
If you go up by fives, the scale of this particular graph is fives because this is 5, or this axis, the scale is 5. 5, 10, 15, 20. Don't put the 10 right here and go 0 to 10, then 15, 20, 25, 30, and go up by fives. You're going up by fives the whole time. Does that make sense?
Yeah.
Okay. So now that you have this done, plot your 7 points onto your graph. Try to be as accurate as you can, although you can't probably get it exact. Just try to get as accurate as you can. Guys have something that looks like that? Notice at the very beginning, okay, when you plot your points, notice there wasn't a huge growth in the very first week, but I am actually a farmer and I know with corn and stuff like that, when you put a seed in the ground, the energy in that seed starts by growing roots. The energy is kind of getting to the roots and it's getting a little root system going before it starts to grow upwards. So you could see how in the very first week, that corn is concentrating on getting roots established before it starts to come up through the ground. But then once it gets up through the ground, you can see here how it kind of goes up at a nice even rate. But then all of a sudden, what probably happened here, lots of sunshine, lots of rain, it had a little bit more of a growth in this week here. And then it kind of leveled out again. So it's not exact every week. It's just depending on the weather and the rain and the sun and so on. Let's answer some questions. Label each axis with the correct variable and title the scatter plot. We did. The independent variable is what? Which is our independent here? Length of time. It's the first one in our scatter plot. And it's located on which axis? The x-axis, which is also another name for the horizontal. Horizontal or x-axis here works. Either one, I'll give you marks. So the dependent variable, what depends on the length of time is the height of corn, and that's on your vertical axis.
Okay. Vertical and X and Y?
You can put one or the other. Is there somebody looking in the door right now? Yeah, who is it?
Yeah, there was, I have no clue who it was.
No, probably a former student. Make a scatter plot of the data using the grid above, and we did. We made our scatter plot. It's already done. You labeled the axes, you put the numbers down, and so on. You put your scatter plot. You're good with 3. Finish the statement about the relationship between time and height. As the number of weeks increases, the height of the corn blank. In general, what's happening? It increases. Okay? And then if the chart or the graph shows that the height of corn did not change over 4 weeks, should the farmer be worried and explain? Can you put down, those people that are online, you don't have to explain yet, but just put down yes or no. If the chart shows that the height of corn did not change on 4 weeks, should the farmer be worried? Yes or no? You guys put yes or no. You guys in here, I'll ask you in a second to put your hand in the air for yes or no. But I want to see what people think here. Should the farmer be worried if the height of corn didn't change for 4 weeks? Just type in yes or no. You guys, hands in the air for yes. Hands in the air for no. That's what I was hoping. Okay? That's what I was hoping. Anybody want to argue why the farmer should be worried? So the corn doesn't change for 4 weeks. Why should the farmer be worried?
Because you wouldn't have his full-grown corn by 6 weeks.
Corn's not going to be fully grown. Anybody else? Anybody online want to talk about why the farmer should be worried?
Maybe that's how he makes his money and how he feeds his family.
For sure, that's how the farmer would make their money is for sure 100% is they want the best yielding corn, the biggest and best yielding corn they can. So yeah, I could see them being worried. Anybody else for yes?
Because between week 1 and 4, there's a 40 centimeter or whatever height difference.
Yep. Yeah, and if it doesn't grow, then you don't get that height of the corn. It's not going to fully mature, right? Does anybody want to argue no? Anybody want to say why they don't think the farmer should be worried? If it was me with my cornfield, which I did have this year, by the way, if the corn didn't grow early, week 1 and week 2 and week 3 and week 4 and week 5 and even week 6, I would be worried. Because I need that corn to go nice and green and tall and get those cobs nice and big so that when I combine it and harvest it, I get the most corn I can. But after about week 8, it's fully grown. And the only thing I want that corn to do is turn from nice, luscious green color to get to that yellowish, brownish color where it's really dry so I can come by and cut it. I don't want that corn to continually grow week after week after week after week after week and get so high it's taller than the school. I want it to get to its tallest height and then I want it to dry down. So would I be worried? Yes, if it was early in the whole cycle of things. Would I be worried? No, if it was later on. Because eventually you just want it to stop. Just like with Julie, remember her height? Okay, remember Julie, we just talked about markings on the wall. Would you be worried if she didn't grow for 4 years? The answer would be yes. If she was 2 or 3 or 4 years old, you would be worried that she didn't grow in 4 years. Would you be worried if she didn't grow when she was 45? I haven't grown since I've been like 20. I've been the same height since I've been 20. I wouldn't worry. If I don't grow next year when I turn 45, I'm not going to be too worried. Okay, does that make sense to you guys? So it's a yes or no question depending. So you guys can put down the following for this. Should the farmer be worried? Your answer should be yes if it's early. Or if it's early on in the first 0 to 6, 7, 8 weeks, the farmer should be worried because you want the corn to grow to its biggest height. But if it's later on, then no, the farmer shouldn't be worried because you just want the corn to dry down once it gets to its maximum height. All right, are you guys good with that? Any problems there? Guys are all good? All right, let me tell you what we are going to do, okay? So I'll give you a second to write that out and I'll tell you how we're going to finish today. You guys hear me at home there still?
Yeah.
Okay, listen to how we're going to finish today, okay? It's a nice Friday. We still have about 40 minutes in class. You guys got a little bit of time at home. The only thing you guys are going to be responsible for in class and at home is this. You have the next page, which does attendance affect your mark? And what I want you to do is complete the scatter plot. And I want you just to look here for a second. This scatter plot here doesn't line up in a nice order in the start. That's not a big deal because you guys just saw a table that did that, which was this one right here. These weren't going up by the same amount either. You just plot your points. It doesn't matter that it's not going up in a nice orderly fashion like this one or like this one. Sometimes you just get these random points all over the place, which is fine. But what you guys are going to do is on your own, you're going to complete this page right here. Okay, first thing. Then secondly, there is a one-page handout in your notes right here. So these two handouts are what you're going to work on in the next 40 minutes, and that's it. Now in Edsby, even you guys in class here, in Edsby, I'm going to post a link that says 2.3 homework, section 2.3 homework. Once you get done your two scatter plots, snap a picture of each. Even if you guys do it when you get home, that's fine. But snap a picture of each, upload that into Edsby, okay? And I want to see both your handouts. 2.3, does attendance affect your mark? And the 2.3, use of scatter plots to analyze data. These 2 pages you are completing from now till the end of the day and uploading a picture into Edsby. You guys all good at home? Hands in the air? Awesome. Okay. So that being said, I will keep my laptop on in case there's a question. Okay. But I am done the teaching. Just know that next week you guys are required to be online, all of you together at 1 p.m. for the next lesson. Okay. And we're going to continue with the scatter plots, but you have the remainder of today to work. If you guys are confident at home that you know what you're doing, okay, you can kind of mute your mic and so on, but I may talk to you at about 1:45. So don't end the meeting, don't leave, but you can kind of tune out. You can put your music on, you can mute your mic, you can work for the next half an hour, let's say. I'll put a timer up and we'll come back and I'll just make sure everybody's good, okay? So I will put a timer on this page here. 2 handouts to do. I'm going to go like this. I'm going to end that.